This video is going to be about a box plot. Box plots are generally used for one categorical and one numerical variable. But I think that's a little advanced for what we're going for in this week. So let's just scratch out one categorical and just say that for now, a box plot is used for one numerical variable. And just next week, we'll extend this video to one categorical and one numerical variable. But for now, just this video will be about one numerical variable. A box plot helps us visualize the measure of center, the median. That is the 50th percentile, the number that puts approximately 50% of the observations less than it. Okay, not the mean in this one. The median specifically represents the median. The box plot represents the median. A box plot also helps us measure, let's fix a typo there, helps us visualize measures of spread, like how wide the data are, specifically the interquartile range. So if you remember all your definitions from before, what we're essentially saying is the box plot visualizes various percentiles or various quantiles. It turns out you can use different quantiles as ways to gauge skew for you. But box plots actually have these extra whiskers that really help you visualize skew more than just reading the quantiles themselves. So let's just do a quick example so I can point out the component pieces of a box plot, and then we will go about doing it in R. So I'm going to encourage us to center all of our box plots at 0 whenever we have one numerical variable and no categorical variables. So as far as this video is concerned, we're always going to center our box plot at 0, and on the y-axis we will put our numeric variable, whatever it is. So box plots get their name because in the middle of them they have a box with a line through the middle. The line in the middle is the median, or the 50th percentile. The line on the bottom of the box, now remember, when you're moving down the y-axis, that's to smaller numbers. This is the 25th percentile. And on the top of the box, you might have guessed by now, this is the 75th percentile. So what we see as the height of the box is the interquartile range. The height of the box is the interquartile range because it shows us the difference between the 75th and the 25th percentiles. Now, in order to visualize skew, a box plot puts these oddly defined whiskers sticking out from the top and the bottom of the box plot. When the whiskers are of roughly the same length, which I tried to draw there even though it's not perfect, then we say that there is no skew. This variable is symmetric. Now on the other hand, when the whiskers are of differing lengths, let's say like this, then we say there is right skew. Now remember, when you're thinking of a histogram or a density plot, skew defines the tail. Because skew defines the tail, and for right skew data, the tail extends off up to big numbers. What we're seeing on the box plot is when this tail extends off up to big numbers along the y-axis, that's going to identify for us right skew. Okay, let's back up and then give a quick example of left skew. So left skew look like this, where the left tail is extending off to small numbers. So that would be an example like this, where the upper tail is very short and the lower tail, the lower whisker, is extending off to very small numbers, just unlike the density plot. that we see here. Okay, let's jump into R, and we'll try to make these plots using the library ggplot2. So we start with ggplot. We'll put in, and let's start with the data set tooth growth. We'll put in the name of the data frame that contains the variables we want to make a plot of. We specify the aesthetic. Now this is the first time we're going to put in x and y variables. We're going to center on the x-axis our box plot at the number 0, and then we'll put in for the y variable whatever numeric variable we want. Then we add a layer of the geometry of interest, in this case a box plot. And here is our box plot of the lengths of guinea pigs' teeth in the data frame and experiment known as tooth growth. So I'm going to leave it to you all to tell me, what kind of skew does this box plot have? Left, right, or none? And in the case of none, we would say it's a symmetric variable. Let's do one more example. I'm going to call ggplot on the data frame chick weight. I'm going to specify the aesthetic where we put on the x-axis the number 0, so we're going to center our box plot at the number 0. I'm going to use the variable weight on the y-axis, and I'm going to once again make a box plot. And here's your second challenge for this video, is what type of skew do we see here? Left, right, or none? And in the case of none, we would call it a symmetric variable. What type of skew do we see with this data set?